Hello and welcome to this presentation. You are going to be learning the new method to model, load, analyze and design steel structure in Tekla Designer, and we will proceed to produce the drawings of this steel structure successfully. If this is the first time you have come across our channel, Soft Freezing Academy, consider subscribing, like the video and stay connected. Let's start. This is the Tekla Structural Designer interface after you launch it from the desktop. At first, we will be selecting the steel structural design code for this project. Under Home tab, navigate to Setting. In the Setting dialog, at default, we have UK setting active. So you can select in this provision and then choose any country code of your choice, or you use these options to actually select country code from this list successfully. And after you select your country code successfully, ensure that you click on active to make it active. For the sake of this project, we'll be considering UK setting. So this one, after which click on the OK option. Now we proceed to create a new project. Click on new option right here, or file menu and then new. So this will create a new project for us. So here we go. This is new project. We want to tie this window vertical, so we have the structure, 3D and ST base. We also have other modeling and design tabs right here. I'll select on this ST base, right click, and then tie this window vertical, so we have the 3D right here, and over here the 2D. Then I proceed to the modeling tab and then construction level. So in the construction level dialog, I will use this option of insert above and then insert two levels right here on that tab. This level is going to be TOX, top of steel, and then this other level is the same top of steel. Here is the base, TOF, which is top of foundation. The stanchion height is going to be 4 meters, which is 4,000 millimeters. And then the apex height of the beam rafter is going to be 2,000 millimeters. After which you click on the OK option. Now we proceed to set the grid lines over here. You select rectangular wizard. So over here in the dialog, click on next, 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 and then the numbers of count in this direction, it is going to be 3. And then the length over here, the length here, we maintain 4,500 millimeters. Click on next. Numbers of count in the Y direction extent is going to be 2, and the length I will maintain 4,000 millimeters. Next, next, and then finished. Here we go. This is our grid line set out for the steel structure. Okay, we want to start to model. So click on the steel column, and then in the property window, I'll expand this. On that top level constraint, we'll be having ST1, characteristics is columns, and then the grade is S355, design sections is UC columns, and then the section itself is 254 by 254 by 89 kg. All right, so I will just select right here, do a window over intersection A3 grid lines right here to have the stanchion placed. The same thing A1 to have the 2 stanchions successfully. After which I'll minimize this window so I can have my static window right here. Okay, so we proceed. I will be clicking in this 3D space so I can enable this frame. Click on the frame, pick along grid line A right there to insert the frame. Okay, so I want to enable this frame. I'll activate the structure and then expand frame provision. Double click frame A to have it in the 2D just like this, so I can model the beam rafter. From here, select the beam, after which you navigate to set the sections of these beams as well as the grade successfully. For the sections, I'll click in these provisions under edit, so I can be able to choose a lower section. I will use 254, 102, by 2 kg. I select that, pick the first point, the second point to have it placed just like this. Escape on the keyboard to get rid of the command, navigate to 3D to have it just like this, and then escape again to get rid of this frame. So I want to populate this along the grid line 1. So I'll select the stanchion or the control key, select as well the beams as well, or the control key, do a window over the base plate just like this to have it select, and navigate to edit. I use copy option from here, pick the first point, place it along grid line C and as well along grid line D. Have it placed successfully. Cancel that, escape from the command, selecting this provision, escape as well. So we'll model the tie beam. Okay, so for the tie beam, get to modeling tab, select on the beam option, pick that beam option. Okay, check the sections, so we go by this same section. All right, so in placing your tie beam, you have to ensure that you are able to pick it at the analytical point. All right, so I'll just get rid of this by escaping from the keyboard. Select in this window before you proceed to pick the beam. Okay, so take the beam section and every other parameters. I believe they are okay. I'll zoom closely, pick the first point, proceed, double click here, and then click once to have that placed over to this direction. Pick here, double click here, and then click here to have it placed successfully. At the apex point, I'll also be having beam, so I'll pick this point here, pick here, and then here. All right, so after which I'll just have to escape from the keyboard. So we proceed to model the brace. Select on the brace. I'll use S brace right here. So I check the property of this brace. Okay, so everything is good. I pick the first point for the brace, zoom closely to ensure that you are picking the right point. Okay, so pick the second point, move my hand upward, double click at the top constraint of the stanchion to have it placed successfully. The same thing here. Okay, and then double click right here to have it placed. I'll also have a wing brace right here, and then here. So in this other provision, I pick to have the wing brace as well. Pick the first point, second point, and then third point to have the wing brace successfully. Also here, first point, second point, double click here to have it placed. First point, second point, double click here to have it placed. All right, so having modeled this successfully, you have to proceed. Click on the validate. Okay, so you can see our model is validated successfully, although we are having some warning signs. So expand this and check what is the warning. Okay, these are load. Okay, you have empty load cases. Okay, we are going to be applying load cases and combination later. So let's proceed to model the we are going to be modeling the purlins. Okay, for the purlins, we will be considering using slope plane. So you click here to make this window active, select on the slope plane right there. So that is applied automatically, as you can see. So I'll activate this structure, and then under slopes, I expand this provision IP1. You can see I double click to make it active, just like this. Navigate to the edit tab and select on the create field. So use this create in field. Okay, so in this property window, expand it. Okay, so I can go by number, and then the number of purlins at which is going to be 5, and then I check other parameters. The characteristics is beam, and then linearity is going to be straight. Okay, and the grade X355. So the design sections right here is not beam, so I'll edit this scroll down and then navigate to this UK PFC channel, select that, and then the sections will also be updated from this provision. I can scroll down to use advanced UK PEFP FC right here. So for the section, it's going to be 150/75 by 18. Select it successfully. Okay, so these are the necessary settings we have done. So just place your hand within this provision, clicked to have the purlins placed just like this at this face of the roof, after which escape from the keyboard and then minimize the property window, IP2, which is the second phase of the roof. Use the create infills options. Here we have 5 of the purlins. The directions is going to be perpendicular. Take note this provision. All right, so we scroll down to make sure the section is properly selected. Uncheck this provision. Okay, and then this is the section as well as the design section order. Okay, so you placed it just the same way. Okay, now navigate to the 3D to have it just like this. Hit on the escape key on the keyboard to get rid of the command, just like this. And then we navigate to the model tab and then use the validate to actually ensure that your model is good. Now we want to proceed to load this model, but before we load it, we need to provide what we call roof panel. Select on that. So we pick the first point, pick the second point, pick the third point, and then the fourth point you have to double click to have it placed successfully. Now proceed the same thing at this face of the roof. All right, after which escape from the keyboard and also validate the model. Everything is good. For the loading of this structure, we proceed to the load options and then load cases right here. So these are default load cases. We have all of this is being applied automatically. Okay, this the first 0 and 1, and then the date load, we are going to be defining it successfully. So you can add other loads using these add provisions, and then you can select the load type and its purpose from here. So we go by this default load for the sake of this project. Click on the OK option. All right, so over here I will choose and select the load case. Then over here I will use the dead load option first. Proceed, we use these options of a panel load, which is the area load. Select right there. So in the property window right here, the load value we'll be using for our dead load is going to be 0.7 right here. So we just place your pointer on the roof, click to place it successfully over here. So we have applied that successfully in the global Z direction. You change this to the services load. For services load, we have 0.1 right here. So use the same option to place this successfully on the faces of the roof. And then for the imposed load, the value is going to be 0.3 right here, kilonewton per square meters. Then for the measuring along element, we are going to be using our projected option. All right, and then this is how it's going to look. You have it placed just like this, and then this other face you have the place as well. So this is how you apply your loads on your structural building using Tekla Designer successfully. Okay, I will click on escape from the keyboard, and then we proceed to create the combinations for this load. So click on the combination option right here. So we use this generate combination based on the code of practice we selected. We won't include all of this. We use final scenario. Click on the next option, and then next again, next again. So we have to check all the directions of the structure successfully, after which click on the finished option to have the combination just like this. Close this window. So here we go. Okay, we want to proceed. Before the design, analysis and design, we need to save the project. Click on save option. So over here we give this project name as SIMT1. SIM-T1. So we'll click on save to save it successfully. Alright, so now we have saved this project. We want to proceed to the analysis tab. So in this analysis tab, we have various panels here. So this is used to analyze and design steel structure at the same time. So you can see analysis and design steel. Okay, so this option is basically used when you are designing both steel structure and then concrete structure. You can use this, and this is for concrete in particular. All right, so we are going to be using this option, so just click on it once. So this is going to analyze this model as well, design it successfully. So let's just give it some time. Here we go. Analysis is successful, but not yet designed. So we need to actually look at what actually causes this issue. Okay, and then the first thing you have to look at is the releases. Okay, select on these options. Now you can see from the colored code right here that we have the stanchion to be fixed, supported. Okay, that is the release is fixed. Okay, for the stanchion. Then every other ones are pinned. All right, so this is wrong because at this point, at this particular point of the connections of the steel rafter and the stanchion is always a moment connection. At the apex point is always a moment connection, and then this other side is always a moment connection. So the beam rafter are supposed to also be fixed. All right, so that is why the members were not designed. Okay, so let us correct that. I will escape from the keyboard to get rid of this, and then I can click in this provision, right click and use the structural view. Okay, now we proceed to select the steel stanchion, but by then we can be able to hold the control key on the keyboard and then orientate this model just like this, so we can see the rafters. So we want to change the release of the rafter successfully. So these are all the rafter selected successfully. Now we need to scroll down, and then you can see releases right here. Select here, fixity and 1. So we need to change this to fix, fully fixed option. All right, so scroll down again, fixity and 2. Select here, use this option of fully fixed successfully. So that is applied on the members, on the selected member. All right, now I will select these provisions and navigate to the review view again. Select here, come to the option of review view, this one, and then get to this option of releases. Now you can see that the color code is being applied to the beam rafter successfully. Okay, I'll escape. We need to proceed. Go to the analysis tab and then use this option again, design steel beam statics. So once you click on that, give it some time to analyze and design the steel beam successfully. So you can see design is successful now. We only have 8 members not designed, which are the base plate. Okay, we'll design that as we make progress. Stick to this video till the very end. Okay, so now we have 71 parts. So all of these members are part designed now. So you can see the section selected for us, and then you can see the utilization ratio in the info box right there. So we can still optimize this, but we'll go by this section for the sake of this presentation. So these are the steel stanchion section selected, okay, after design, and then you can see the U ratio as well, 0.613 right there. Okay, so we are good. So you can select any of these and then right click. So over here you can be able to look at the check the member statics, so you can see all of the design, movement, and everything has passed successfully. If you want to look at the analysis of this, just right click from here and then go to the result view, and then over here you can be able to click on the result right here, and you can see the axial forces. If you select here, moment in the measure, you can also see the moment in the measure right here. If you want to see the reaction, activate the ID and click on reactions right here based on the spread and as well as services right here. Okay, so we navigate back to the model itself. Okay, let's just use these options of review view to see all our member parts successfully. Now we want to proceed to design the foundation, okay, for the steel stanchion successfully. Now we navigate to the foundation tab and then use this option of part base. Select it right there. So this is the property of the part base. At default, you can see the section in the Y direction and X direction, as well as the depth right there. Concrete class can be selected through this provision. So we go by this 32/40 concrete class successfully. So everything is good. Over here for the reinforcement, top bars is not selected. We are considering bottom bars in the direction 1 and 2 successfully. So these are the cover for the bottom, top, and the sidebar successfully. Okay, the area of concern here for me is this bearing capacity. So I will change here to 150 kilonewton per square meters, and then over here we'll also change it to 150 kilonewton per square meter. Okay, so having changed all of this successfully, we proceed. Just do a window over the column points. Release your hand right there. Sorry, we were working on this window and we choose to apply it on this window, so it's not going to work. Okay, so you can use this option right here. Click in this provision. If you select in this space and then you use this provision, you can be able to toggle between the ST base and then the 3D successfully. Okay, so let's just escape now. Let's escape from here and then click on this window to activate it now. Okay, then escape, click again, navigate to the part base again. So now this window is active. You can now proceed and cross check your settings. If they are still intact, the soil bearing capacity have changed. So I will be considering 150, just as I said before, and then here is 150. Okay, another thing I want to look at is the bar spacing. Okay, I'll use 150 as well for the reinforcement spacing. Okay, just like this. Then the top cover, bottom cover, and side cover 40 millimeters is okay. After which, do a window now over the gray line or over the column points, just like this. Release your hand to have the footing placed successfully. So these footings are not yet designed. What you do now, navigate to the design part basis, click that options, and then this has been designed successfully. Now you can see if I activate this window, zoom closely, and then come to this option of statutes, click, you can see that the footing, 8 of the footings have been designed successfully, and you can see the selected sections and then the depth successfully. So for the sake of anchor bolt, we are going to be increasing the depth of this footing. Okay, so we need to select the footing, select the first one, or the control key, select every other ones, just like this, get them selected, just like this. Okay, so having selected it, over to this provision of depth, select here, I want it to be 400. All right, 400 millimeters depth. I'm selecting the provision to apply the effect successfully. So we have to design the footing again after changing the depth. So ensure that the auto design is not checked. These provisions, leave it blank. Okay, now I'll select in this provision in this 3D space and then navigate to foundation again. I use this same option so I can redesign the footing based on the dictated depth. Okay, so I click right here. That has been designed, but some of the footing has failed. Okay, so if I escape from here, you can see that this one failed, this one failed, you can see. Okay, so what we do now is we just have to select all of it again. We need to adjust the X and Y the dimension. Okay, we take this to be 700, take this one 700 as well. Okay, make sure the auto design is not checked. Escape from here. Here we go. So I can even navigate to the structural view right here, just like this, and then save this model first. Navigate to design. Okay, foundations, and then design part basis. Okay, now you see all as past design with the given section at U ratio 0.7. That is very good. Okay, now we proceed to design the base plate. So I will navigate from here to the structural view, so you can be able to see the base plate micros, which is this one. Have that select. Okay, so now go to the design tab right here, so you can see the check base plates. Okay, so base plate is already there, and these are the informations as well as the necessary parameters and the size of the base plate at default. So we go by the default, and then we click on the check base plates. So once you click on the check base plate, you can see that we have some of the base plate passed, and then some at failed. This one at the center has passed, then this other one failed. So let's be able to check what makes it to fail. I'll select on this, right click, and then you can use this check base plate, this number, click right there. So you can see this failed by share, and then this one also failed by share. How do we correct this failure? Close this. I will show you now. Select on this, right click, and then use this option of edit. Now under bolts, if you come over here, you can see horizontal shear transfer frictions alone. Select here and choose frictions and shear on bolts. So just select that option and click on the OK option. Now right click on this and then use the check again. That is corrected, you can see. So the same thing we'll do to other ones that failed. Select this, right click, edit, change these options to frictions and shear. Click on the OK option, right click on it again, so you can check it that has passed successfully. Okay, now over here, select this one, right click on it, and then use these options, edit, navigate to friction and shear on both. Click on the OK options, and then right click on it again. You check the base plate again. That is corrected, everything is good. The last one here, select it, right click, and then edit it over here. Choose the option, click on the OK, right click right here, and then check it again. This has passed as well. Alright, so everything is good now. You can see if I escape, all the base plate has passed. Navigate to these provisions, all the footings has also passed design successfully. Alright, so now we are good. We want to proceed to produce the detailed drawings. So I will select on this window, right click, and then I can use these options, move to previous tab, so I can have a single window just like this. So this is the ST base. I will select here, right click, and choose to structural view over here. I can also right click it and be able to use these options of structural view to have this. So this is going to be our layout. Okay, for the drawings, go to the drawing tab, and then we use this option of foundation layout. Click right there. So once you clicked it, you have this window for the foundation layout. I will have to decrease the text height to 2, and then scale 1 is to 50. I'll maintain that. Click on the OK option. So this will automatically launch AutoCAD and takes the drawings of the part footings as well as the plan of the base plate to AutoCAD. So let's give it some time to transfer the drawings successfully. At this point, if you are yet to hit on the like button, like the video. If you are yet to subscribe and stay connected as we make progress to generate drawings for this design. I click on the no option right here, expand this window. I will expand this AutoCAD window just like this, so you can see that we have just one part base. So all the sizes are the same. This is 8 number, you can see, give us 1, and then it is 8 what number. Okay, now these are the plans for this structure. So we navigate back to Tekla Designer. We want to produce some other design, some other details, some other drawings. Okay, so but I will get to the modeling tab right here, and then navigate to 3D right here. So I minimize this and then click on validate. Here we go. I will check this option. I'm having 3 frames right here. 3 frames. So I want to view the 3 frames. Let me see. Okay, this is one of it. This is the 3rd frame. And then this one is the frame along the line A. Alright, this is good. Now get back to drawings. Okay, I'll get back to 3D right here. So I will use this option of drawing management. Okay, so once you select that, you have this general arrangement options. Just click on add from here, and then for the content of this, I will be considering all of the levels. So I move this here, the frames I move this here, the slopes I move this here. So the slope will now tell me the details of the purlins, all right, on the roof. Successfully I click on the OK option, and then I go to the view drawings option. Here I will be using scale 1:50, so the drawings can be bigger. All right, so for the text height I will reduce it to 2, and then over here it's going to be plan sections and elevations. Successfully click on the OK option. Here we go. So you can see that we have created the drawings for our steel structure that we have designed in Tekla Designer. So this is the detail of the plate, base plate successfully. You can see over here. And then this is the details of the members and the sections labeled successfully. This is the base plate sections labeled successfully. And these are the sections along the line A. Also, this is the plan of the roof that contains the purlins and sections successfully. So this is how you can create drawings after designing your steel structure using Tekla Designer successfully. So I believe you have learned how to successfully model. You have learned how to load, analyze, design, and then produce drawings. So if you want to produce the report, it's the same thing. Select on the member, or you can decide to use. You can watch one of the video on our channel that I produce reports using these options of member. You can use these options as well. Click on add from here, and these are the members. You can choose the one you wish to actually produce report for. All right. As well, you can select on the member, right clicked, and you see a report for member. So once you click here, you can see over here, this is the report being created for that particular members I've selected successfully. So I can hold the control key zoom so you can see it closely, just like this. And then if you scroll down, you can see the summary of the report for the member is listed in this table successfully. Okay, so here we go. We are done with our design for this model. Okay, if you have any question or discussions, let's do it in the comment section. Drop it in the comment section and I will respond to it successfully. If you want to learn this particular software to become pro or pro user of it, you can reach to me through the link in the description of this video, and we have a group chat where we ask questions, answer questions, and learn. Okay, the link is also in the description of this video, so you can just use the link to join the group chat successfully. Have a great day, and then we'll stop here. See you in the next presentations. Bye for now.